Hi there, algebra students. So this is meant to be a little bit of a review over how to answer some of the problems that you may have seen on your homework regarding functions. And so one type of problem gives you a graph just like you see here. And your responsibility for this graph is to do a couple things. You have to list the domain, you have to list the range, tell if it's a function, and then explain how you know whether or not it's a function. Okay, so in order to do the domain and range, so I want to remind you, pardon me, I'm going to remind you that the domain is the set of all inputs for your relationship. And so if I look at inputs, inputs are the x-axis values. So I'm just going to go through, I'm going to tick mark wherever I see a value that matches up with one of the posted plotted points. So I see a point plotted at -3, so I'm going to make a mark there. I'll even write -3. There's a point above -2, above -1. There's one above 0. There's some points above 1, 2, and 3. And so I've listed out all the x values of these points up here. And so by doing that, I've actually created a list of the domain. Those are all of the input values that are graphed. So I'm going to go ahead and use my set notation, -3, -2, -1, 0, 1, 2, 3. And I've got my entire list of the domain now. So the range, which I'll do in red here, is the set, I'm going to put my of all outputs. And so outputs are y values, and so I need to make a list of all the y values that are relevant, and I'm going to do that over here on the right. And so I'm going to find all the places where a point is plotted. So here's one, and that is, there's one right there, that is at 2. There's more points plotted at 3, 4, 5, 6, and 7. And so I'm just reading the y values off of this set of points here. And so again, I've created my entire list of the range, and I'm going to list that out in set notation with my braces. So it's going to be 2, 3, 4, 5, 6, and 7. Okay, so something to think about here is that one of the reasons we use set notation is that it's mathematically how you talk about what a list is. It's a list of numbers, and that's how you indicate it in math. It's kind of like punctuation. The other thing to notice is that I listed the numbers in order from least to greatest. And while that's not sort of a requirement, it's definitely something that makes your sets easier to look at and easier to read. So really suggest doing that. It'll help you make sure that you don't miss anything. It'll help us as your teachers make sure that you don't miss anything too. All right, so now we have this question, is this a function? And so if you recall, a function is a set of inputs and outputs where there is each input has exactly one output. And so I'm going to look at a couple of my inputs here. If I look at the input of 1, I can go up to see how many outputs there are. There's one output there, and then there's a second output there. And so the input of 1 actually has 2 outputs. And because it has 2 outputs, I know that this is not a function, because for it to be a function, each input can have just one output. You may think of it that way. You can also think of it in terms of a shortcut. If you draw a vertical line, I'm going to try to be a little bit clever here. If you draw a vertical line and then drag it across, you can see I hit 2 dots there, I hit 2 dots there. And so the vertical line test helps you to see that for a given input, here the input would be -3, I hit 2 outputs of 2 and 3. Here the input is 1, and I hit the outputs of 5 and 6. And so those inputs have more than one output. As a consequence, I can say, is this a function? Nope. I got to get my pen back out. Nope. And if I say, how do I know? Well, it is not a function because, and I'm going to be specific here. The more specific you are, the better. I'm going to say because the inputs of -3 and 1 have more than one output. So you could just say there that it doesn't pass the vertical line test, but that's just not as strong a evidence as saying is -3 has more than one output. That means it's not a function. All right, let's keep going. Let's look at a table now. I have this table down here. And for this table, I need to identify whether it is a function or not, and also tell the domain and range. So domain and range are relatively easy. I'll go back to my blue for my domain. Set of all inputs. Inputs on a table are usually on the left. And so my inputs for M are 3, 4, 5, and 6, and I don't have to list 6 again. I've already listed it. So I've got 6 here twice, but I don't have to list it twice in my set of inputs because it's the same input. Let's do our range. My range starts at 19, goes to 34, goes to 89, and then does 112. And 112 is repeated, so I don't have to write that twice. You might notice it's already in increasing order. So let's go ahead and consider the next stage here, which is to decide whether or not this is a function. And so I have to look and see if there are any repeated inputs. That was the test we kind of talked about in class, and I noticed that there are repeated inputs here. 6 occurs twice in this table. But if I look really closely, I notice that 6 has an output of 112 in both cases. And so if I were making a map of this, it would be 3, 4, 5, 6, and I would have 19, 34, 89, and 112, and my map would show that each input, here are my inputs, each input has just one output. So it is a function. Each input has just one output. And so we can tell it's a function because there are no inputs that have more than one output. All right, let's keep going. So this tells us to complete the table, then find the range for the given domain, then graph the function. Okay, so the domain, it tells me, is -5, -3, -1, and 0. And since that is domain stuff, and I've been doing domain in blue, I might as well keep that up. Since that's domain stuff, I better put that in my table. And so I'll have -5, -3, -1, and 0. And I'll ask you to consider why I put those in the X column. If you recall, domains are the set of all inputs, and so therefore the domain should end up in the input column or the X column, also known as the independent variable. Lots of different words flying around here. Then I have to use my rule to figure out what would go in the Y column. Now to do that, I'm going to do a lot of plugging in and then calculating, and that's how you use a rule like this to find out the output. So I take I take my X, and I'm going to start with -5, and I'll do 2 times -5, because I'm plugging it in for the X, plus 9, and that should give me the Y. So 2 times -5 is -10, plus 9 is -1. Okay, I'll do it for the next one. 2 times -3 plus 9. 2 times -3 is -6, plus 9 is +3. 2 times -1 plus 9. 2 times -1 is -2, plus 9 is 7. Whoops, sorry. 7. And then 2 times 0 plus 9, that's easy. 2 times 0 is 0, plus 9 is 9. Okay, and so I need to write my range out over here, which I think I've done in red all along, so might as well keep that up. The range should be -1, 3, 7, 9. You might notice that we made a little bit of a mistake. We should have put a list notation there. Let's go ahead and plot some points then. I need to go to, starting at 0, 0, that's the origin right here. I'm going to go 5, whoops, I'm going to go 5 to the left and then 1 down. And I'll zoom in here so I can make a nice line, a nice point. That is going to be right here. Okay, -3, 3, so I go 3 to the left and then 3 up, and that will end up right here. -1, that's 1 to the left and then 7 up, so that's 3, 6, 7 right there. And so I get that point. And I'll get rid of this point here. Whoops, I plotted that at 6. Pardon me, it should be right there at 7. Okay, and then 0, 9, I don't move left or right, and then I go all the way up to 9, which should be right there. Now, because the domain is restricted, I'm not going to connect the dots. Those are the only inputs and outputs there. You can notice because it started out as a function, y equals 2x plus 9, it's definitely going to pass that vertical line test. So I'm in good shape here. All right, let's do one more. Inputs and outputs, domain and range, x's and y's. I have my map, I have my function rule. So I'm going to make my domain here as a list. Whoops. There we go. It goes from -2 to 0 to 1 to 2 to 3 to 4. I'm just listing all of these numbers here. And then the range, I'm going to list all the numbers right here. And so the range is a little bit smaller, 1, 4, 9, 16, 25. Okay, and so now I need to kind of figure out this function rule, and something we're going to talk about in class next time is you'll see how you can use a function rule, how you can think about how to go from the inputs to the outputs using sort of a guess and check method. And so I'm going to think about 0, and so I'm going from 0 and I'm getting to 1, so there must be some kind of addition involved. So I'm thinking that I could take 0 plus 1 and get to 1. But then if I try that for 1 plus 1, it doesn't quite work because I only get to 2. However, I'm noticing a pattern here. These are all square numbers. 1, 4, 9, 16, and 25 are all perfect squares. And so I'm going to think about doing something like this. 0 plus 1 squared is equal to 1. 1 plus 1 squared is 2 squared equals 4. 2 plus 2 squared equals, 2 plus 2 is 4, squared equals, oh sorry, I added 2 instead of 1. 2 plus 1 is 3, squared equals 9. 3 plus 1 squared, 3 plus 1 is 4, squared is 16, so it seems like it's working. And then 4 plus 1 squared equals 25, because that's just 5 squared. I'll try -2 plus 1. -2 is -2 plus 1 is -1. -1 squared is 1. So it sure seems like my rule is y equals, I take the input plus 1, and then I square it. All right, hopefully you found that helpful as a nice little review. We'll see you in class.